Imagine delivering a project on time with code that compiles and a perfect interface, only for the client to say, "That's not what I meant." This happens because at the start of a build, stakeholders rarely have a perfect vision of the end result. They have vague goals, conflicting priorities, and often lack the technical vocabulary to describe what they actually need. If you start writing logic while those goals are still fuzzy, you are simply gambling with the project's success. Technical excellence doesn't matter if you've spent months solving the wrong problem. To close this gap, engineers use a systematic framework called requirements engineering before a single line of code is committed. This is the translation layer of the project. It's designed to filter through the initial human chaos and produce a structured technical blueprint that a development team can actually follow. The process begins with inception. This is where you identify every stakeholder involved and establish the scope, the absolute outer boundaries of the problem the software is intended to solve. From there, you move into elicitation. Developers and clients collaborate to map out how the system will be used, what specific data objects it will handle, and what services it must provide. This is where conflicting viewpoints surface. The marketing department might want a frictionless interface, while the security team demands multi-factor hurdles, and the end users just want the page to load faster. The data gathered at this stage is raw and contradictory. It's too unstable to code from, so it has to move further down the pipeline for refinement. In the elaboration phase, engineers parse that raw text to extract concrete analytical models. They categorize the requirements into functions, features, and system behaviors. During negotiation, they reconcile stakeholder requests, ranking them by priority and assessing the technical risks. The goal is to reach a consensus on what is technically and financially achievable. By the end of negotiation, impossible demands are removed so that every party is aligned on the final plan. This forged logic provides the stable foundation needed to create the project's definitive technical contract. All that negotiated data is formalized into an industry-standard document, the Software Requirements Specification, or SRS. Following the Carl Weaguer's template, the document begins with an introduction locking in the project's scope. The overall description defines user classes and operating environments. System features lists explicit required actions. External interfaces specifies system communication, and non-functional requirements defines performance goals. The completed SRS acts as the project's technical anchor. It gives the development team a definitive reference point, ensuring the final code aligns with the negotiated needs of the stakeholders. Even after the document is finalized, the pipeline doesn't simply stop. A static document that is filed away and ignored is useless. The first step is validation. The team uses strict checklists to review the SRS, looking for any lingering ambiguities or unachievable goals that might have slipped through the earlier phases. Because clients will inevitably request changes as the project is being built, the team uses requirements management, a protocol to track and control those updates without losing sight of the original goals. Software engineering is as much about understanding people as it is about writing code. Requirements engineering provides the process to ensure that when the first line of code is finally written, it's solving the problem the stakeholders actually have.